I'm Debo Dutta. I'm a distinguished engineer at Cisco. And today we are going to just continue the conversation that Vikas started. And we'll talk about, just double click on the Kubeflow and what our story is with, how do we do actually AI at Cisco with Kubeflow. And just to give you a context, I run a small AI center at Cisco, look at customers' problems, understand algorithms, data science. So I'm happy to answer any questions even beyond just Kubeflow, just about all advanced AI stuff too. So we are going to talk a little bit about what is AI/ML. I know everybody has a different way to look at what is AI/ML, but for this conversation, I'll have a very simplified view. Then we'll talk about how we are simplifying our customer's journey with Kubeflow, and we'll talk about one advanced topic that we believe will help our customers, which is AutoML. And by the way, just as a quick note, within Cisco, we actually have been doing AI and ML infrastructure for a while. That figure that you see is from 2009, where we actually built accelerated machine learning inference device using our TCAMs on our Catalyst 4000 switches. I was involved with that effort, so it's like really old now, 2009, when the world wasn't talking about AI and ML. So I just wanted to give you a simplified view of what is AI and ML. So as an engineer, I have a very abstract and simplified view. Let's consider AI and ML is all about learning from data. So what does learning really mean? So let's assume that you have a model, a mathematical model that looks like some kind of a graph. It's a neural network with multiple layers. But essentially what you have is this graph is characterized by a huge number of parameters, theta. And you have, and your observed data is your x comma y tuples, where x is your observed data, y is what you have found out about something that you want to find out. So for example, for images, these x's are all images of cats or dogs, and y's are the labels, whether is it a cat or is it a dog, so 0 or 1. So this system, if you could find, looking at observed data, if you could find all the theta, you have you've learned the model. That's what, when people say, oh, I'm going to learn the model. So that's what it means. It means you just have to find the theta, subjected to some kind of a loss function. You want to learn, you want to optimize and figure out what is it that you want to try to minimize. So the minimization is typically a loss function, and we have an objective to optimize. And then we run standard optimization algorithms. And this is a multi-decade-year-old field. It's not something that just arrived 5 years ago. And typically the hottest algorithm that's used today in the community is variations of gradient descent. And if you Google for stochastic gradient descent and gradient descent, these are really old algorithms. It's well understood in operations research for decades. So of course, there's been a lot of improvements in the field in AI and ML in the last 5 years because of, as Vikas mentioned, compute power, distributed systems, and availability of data. We didn't have the kind of training data we have today. Even for looking at diabetic retinopathy or looking at cancer images, we didn't have so much of images. It's not just cats and dogs. So in reality, enterprises, healthcare, fraud detection, they have access to more data. They have access to more distributed frameworks, so you can actually do this kind of learning. And when you look at engineering, it's non-trivial. Even if you consider a single box, like the UCS box that you see there, if you want to take this kind of learning workloads, you will have to write it in a form that a system can understand. Typically, you'll take PyTorch or TensorFlow. If you look at that stack, it's a pretty deep stack. Essentially, you'll have to do a lot of computer sciencey stuff, like compiler optimizations to take the take the representation from in TensorFlow all the way and map it into a hardware accelerator, which could be a GPU, as Vikas mentioned, or it could be in an IoT device. You could be using FPGA or a DSP block, or on your iPhone, you have your mobile AI blocks. So it is non-trivial, and I've not even talked about the distributed system stuff yet. So that is what we understand as AI, and now this kind of workloads are getting deep into enterprises, as Vikas mentioned. So now how do we simplify our customer's journey? And what do we mean by our customer's journey? And so if you think about the AI life cycle, it's a lot of stuff that happens other than the math that or the optimization that I just talked about. So you have a lot of data ingestion, a lot of ETL, transformation. After doing all of the data cleaning, you do training. And training is basically you find out the thetas or the parameters of a model that we just talked about, and you run these optimization algorithms. And then you build a model. And that's what your model. A model is basically parameters of the basically it's a compressed version of all the data that you've seen. From an abstract point of view, it's a compressed. So model is seen as a way to compress information, not just data. So once you build this small complex compressed model, which can be fitted typically using hundreds of megabytes as opposed to terabytes of data, now you need to do the model validation. Is my model accurate? Is it performing the right way? Is it giving me the right metrics? And then you iterate that, and you say, can it be trained at scale? Because you typically, data scientists look at a model with small data sets. If you go to kaggle.com, you'll see all the data sets are pretty small. But then you also have to train at scale. You have to roll out. You have multiple. So data scientists might build like tens or often tens of model variations. And you have to do A/B testing after serving those models. And then you have to deploy them. And once you've deployed them, it becomes a massive DevOps or DevSecOps problem of understanding which models worked, which models didn't. And you need to have a pretty competent logging infrastructure for that. So you're getting back into traditional infrastructure problems. So as you've seen, all the fun part of AI and ML that everybody talks about, the cats and dogs story, is just that one block. So now map this entire thing into a scenario where our customers are choosing different clouds, and they're also building their own data center on premises. So I'll go back to that previous slide. So let's map this one. So on premise, it's very easy. You map onto servers, and we have servers, as Vikas talked about. But in a multi-cloud scenario, you may have your private data center with UCS servers, and you may have different clouds for doing different things. Actually, if it is well understood anecdotally that people tend to bet on multiple clouds and build their own data center simultaneously. So how do you map this? How do you map the entire complex life cycle onto this? So when talking to our customers, we realize that this is going to be a real challenge as traditional enterprises embrace AI in their life cycle. So our strategy is very simple for this problem. We want to have consistent set of tools and processes that we ourselves first consume, and then we suggest to our customers. And it's via open source. We believe that AI is early, even though there's been a lot of initial success. Enterprise AI is super early, as Vikas also alluded to. And right now, innovation is happening in open source. So if you see the top GitHub repository in AI, it is TensorFlow. It is not some bespoke product built by an enterprise company today. So it is open source. So essentially, open source gives us no vendor lock-in. It allows you, it can run anywhere. And tools like TensorFlow and PyTorch are really getting traction, and they are validated at scale. I mean, Google runs TensorFlow at Google scale. Facebook runs PyTorch at Facebook scale. Amazon is running MXNet. So these open source tool chains are not early. They are pretty mature. Honestly, what is lacking is the AI lifecycle management, which people are addressing today. Different cloud vendors are addressing their own way. And in open source, there is a new project in town called Kubeflow, which was started by Google, but it's a community project, which the goal is to run AI workflows on Kubernetes-based cloud environments, anywhere. So anywhere you can have a Kubernetes in a Kubernetes native way. So our hope is that this is going to actually bring consistency and order to this complex lifecycle management across multiple clouds, assuming that the customer is running Kubernetes, which is a very fair assumption, and they're also running either PyTorch or TensorFlow or MXNet. So that's our story. And in order to, and if we double-click that Kubeflow block, this is what we get. So we, in our mind, in fact, we are developing this and testing this and consuming this. We have infrastructure, which could be private infrastructure like UCS servers, like the box that you see there, or it could be public cloud, where you would have GPUs or TPUs or any kind of accelerants, and then the layer on top is Kubernetes. Let's be Kubernetes native. Put Istio, which is the service bus, or Knative, which is the new application framework, and on top of that put Kubeflow, which actually is a combined block for Kubeflow, TensorFlow, PyTorch, all the AI ML tools. And on top of that, you have your advanced machine intelligence tools, and we'll talk a little bit about that. And on top of that, you have your domain-specific enterprise apps. And if you double-click Kubeflow, so essentially, Kubeflow has two parts. Kubeflow basically gives you the DevSecOps layer, the plumbing layer, to run TensorFlow, PyTorch, all kinds of ML frameworks on your Kubernetes cluster. It also gives you a bunch of essential machine intelligence tools, which includes Jupyter Hub, so that your data scientists can iterate quickly. It gives you all kinds of hooks to TensorFlow, PyTorch, and it will also very soon give you model management, which is a very fundamental lifecycle management tool. And then Kubeflow will enable advanced machine intelligence tools like hyperparameter tuning. It already has something to do with hyperparameter tuning, and we are working with the community to help the community realize AutoML. I think that's where enterprises will move towards, in our opinion, in the next few years. So we joined hands with Google like around 6 months ago, after they announced this, and we realized that we are going to, instead of building our bespoke tools, we're going to just pay our technical debt once and build it in the community. And we are co-building this with Google at this point. We are one of the top committers in the community. So if you look at the graph on the right side, in version 0.3, if you look at the 2 of the top 5 committers, the last 2 actually, they're from our team in Cisco. And this is just the beginning, because we joined in 0.3. Before that, we were not participants.
Out of curiosity, you're talking about Cisco consuming these tools. What are you using it for internally?
So yes, that's a very good question. So we are actually, we have our own set of workloads, so security. Okay. We have an enterprise collaboration business where we identify speakers and all kinds of audio and video workloads that we can go into. So our goal is to first, we understand the workloads, and actually this is a good segue. So if you go to mlperf.org, you will see that the industry has a standard set of 8 workloads for deep learning, and I think many of them are actually being used inside Cisco, many of those 8 workloads. So that's a good open source reference for what the kind of workloads we are looking at.
Okay, so things all around the WebEx systems, all the
security
side of things,
yeah.
data analytics.
Yeah, security is heavily using machine learning today. So, but our team, my team's goal pretty much is to build the tools that we need to do this while we understand our workloads. So we understand workloads, build the best-in-class tools, and work with Vikas to ensure that they are validated on the hardware that we build. And so if you look at our contributions, we have like three major contributions for this release. So we've done a validation and benchmarking framework, which we'll talk about a little bit. Then, and we've introduced PyTorch support. Initially, Kubeflow was heavily supported by Google because of TensorFlow, but there was a lot of requirement from our customers that we saw a lot of PyTorch customers. So we said we should have PyTorch compatibility, and so we doubled down on that. And then we also contributed some algorithms to hyperparameter tuning, because as you build models, the hard part is to tune the parameters of a model. And the next hard part is to even do everything automatically instead of just come up with the models themselves. So we've done the first step. And then now currently we are also engaging with the community on how to do AutoML within Kubeflow. And we'll just go over this a little bit. So if you think about this also helps you understand how Kubeflow works today. So Kubeflow is Kubernetes native. So everything is a Kubernetes CRD. So we created operators. So there was a TensorFlow operator, and so together with the community, we've built a PyTorch operator so that we could run PyTorch jobs. Kubernetes can then schedule PyTorch jobs. In this version, we have an early version of the PyTorch operator. And this is the way now people can very easily run PyTorch jobs using Kubeflow. And again, as we said, that it is early. We are making it battle hardened because so that our customers have the trust that it's something that's enterprise ready. Okay, so our goal essentially is, as you'll see, that it is to make Kubeflow enterprise ready, because right now the community is ensuring Kubeflow is cloud ready. But our goal is to ensure it's enterprise ready with our stuff. And the second big contribution to the community is Cubebench. So suppose somebody runs, one of our customers takes Kubeflow and runs it on our servers. How do we know that it's actually working as it should? So there was no validation framework to validate and stress test Kubeflow. So we contributed that module to Kubeflow starting from 0.3. And again, it's early. We just have simple benchmarks running on it. We want to get to distributor training. We want to ensure that all the benchmarks that the industry is talking about in MLPerf, and that's why we're also engaging with that community to ensure that we can validate for large jobs that our customers have. And that way, we know that it's getting battle hardened. And in addition to all these enterprise testing stuff, we are also trying to work with our customers to see how Kubeflow can integrate with their brownfield, which is basically data lakes, data streams. So how do we do that? So we have, as Vikas mentioned, we have a significant business there, and many of them, and the data resides in these data bodies. We are figuring out different connectors and architectures to do that, and we can go into detail in the Q&A section. And also, because we are completely, so our goal is to build all of this in the community so that our customers, if they start embracing Kubeflow, and the customers have shown a lot of interest, then they get all the advanced features very easily without having to, for us to build separate tools for them. So we are looking at model management features within our community. We are trying to identify how to integrate with different pipelines, Apache Beam pipelines, and so forth. And we'll talk a little bit about the researchy stuff we are doing. And if you've noticed, NVIDIA also has this Rapids framework. And Kubeflow, as a part of our Kubeflow, we are also trying to incorporate, I didn't put it in the slide, but because it's very recent, we're trying to work with the community on Rapids and Kubeflow. And having said that, so this is our pure community contributions to building enterprise-grade AI tool chains that would help us as well as our customers. But looking forward, if you look at the crystal ball, where do we see things going? And this is where some of the things that we are doing in my team is to understand what AI problems enterprises will face. And we believe that AutoML is going to be a big thing in enterprises more than the web scale companies, because if you look at the complexity in training even ResNet, which is the simplest of all deep learning models, it's quite a bit. You have to figure out how do you even to choose random number seeds is a problem. And if you run the same model training 10 times, more than half the time, you might get slightly different numbers. There might be a lot of variation. So the question is, for an enterprise customer who's just starting this journey, this is a nightmare. Even to train models, figure out hyperparameters, you figure out what type of model to use. Even for ResNet, I'm just using ResNet, but you could just substitute that with any, it's the simplest model. You will have multiple variations of that model that you could choose, multiple implementations, faster and faster methods. Every year there'll be somebody who's come and said, I've increased accuracy by 2%, 1.5%. So you have to keep track. So how do you design models automatically? And so AutoML is basically this bunch of tools and techniques for automatically designing and fine-tuning models. And it has a lot of sub-areas, but one of the things that we believe is going to take off is, so there are two things we believe is very useful. Hyperparameter tuning. For a given model, we have tons of hyperparameters. What are the right hyperparameters? That's already happening inside Kubeflow within an effort. The next part is, I don't know what model topology to use. So that's a new area which has just started to take steam. It's called neural architecture search. Sorry, I keep saying network because at the end of the day, it is a graph. It's like designing your network. So think of it from the networking perspective, right? Initially, if given a network topology, I can do traffic engineering to optimize my topology, but I could also build better network topologies that will work fundamentally better for my traffic routing. Similarly, for neural architecture search is the equivalent of building better models ab initio without just optimizing an existing model. So it's a new area. It started generating a lot of interest because of a Google 2017 paper, and it is much more complex than simple hyperparameter tuning. We can go into details. We should have time. But it is a very recent area. And there's a lot of hype and a lot of promise of AutoML in the industry. So we said, when we looked at the hype, we said, we need to understand the hype and see if there's something enterprise grade that we can do over here. So what we started looking at we looked at this area very, very carefully, talked to people in the community, in the research community, and we said that it is not a hype. It is very early. You can, using optimization, create models that can train in half the time or 1/10 the time. It is possible. And in order to do that, we created our own neural network construction algorithm, and we showed that you can get near state of the art in less than 1 GPU day, whereas If you take the standard benchmark models, it's multi-GPU days using the same hardware. Because as Vikas mentioned, that time to train is a business metric. So what we want to help our customers with is not just give them the hardware, but also the ability to shorten their AI life cycle. And we know that this works because we've validated this, and we've actually open sourced this algorithm. And we can give you the links to this. But and we not only open sourced the algorithm, we realized that right now AutoML is pretty much being driven by the research labs in Google, Facebook, CMU, DeepMind. There does not exist till today a framework to benchmark them, compare them for an enterprise customer, or to play with them. It's very hard to use some of these researchy tools. So we created an AutoML framework, and we put that out. And I think it's getting quite a lot of GitHub stars. And I don't want to go too deep into it, but essentially, what was that intuition? So if you look at a standard deep learning model like ResNet, at every step you could choose a lot of filters that you want to use on top of your matrices to come up with the internal state. So we actually decided to look at those filters, see how they are learning, and make changes to the topology as they are learning, as opposed to traditionally you let the training algorithm complete, you see what was their accuracy, and then you make the changes. So we tried to do very dynamic training, and we actually had to instrument TensorFlow parameters, because when you use TensorFlow, people use it like a black box. We said we can't use it like a black box because we need to know what's happening while we are training. So we instrumented all this. So, and that's pretty much our intuition. And I can explain more during the Q&A, but this is our open source contribution on GitHub. And essentially, this is the final reason is that we want to do all of this and integrate it with Kubeflow, so that when our customers bet on Kubeflow and start using our UCS servers, they get all of this goodness automatically without having to learn new software tool chains. So we've already started working with the community on what should be the right AutoML abstractions, how should we do this in the community. So this is ongoing work. But just to step back, the reason why we are investing so heavily in Kubeflow is because we see a need to have consistent lifecycle management tools, which are not there. And it's our way of simplifying our own AI/ML life cycles within the company. And there's a lot of work that goes into making this battle-hardened, and the community is going to do this together. So we want to be part of that community that battle-hardens this whole thing. And that way we get the benefit of a battle-hardened, consistent stack that performs beautifully on our hardware first. Sorry for the really quick rush. But
no, it's okay.
No,
you seem passionate about it, which is why it was, right?
Yeah, I'm passionate about this. I really believe this is going to make a big impact in the industry.
Where things stand today, obviously AI and ML is quite popular. Everybody's talking about it.
Mm-hmm.
Is it easier for a customer right now to use some of the pre-built frameworks on public cloud platforms to adopt AI and ML rather than having to build it yourself using validated designs, for example, on-prem? Or is there an advantage of doing that other than privacy and the data locality and residency in your view?
So I think there are multiple ways to, that's a great question because it has multiple answers. So if you are just looking to use an AI ML tool as a scientific calculator, I'm just oversimplifying it, you just need a GUI, then it doesn't really matter where that AI ML tool runs. The question is, it's very easy to get started in the cloud. In fact, when my team started looking at AutoML, we actually started in the cloud. We rented the servers from a well-known public cloud provider. But then we saw that as we scaled, it was becoming harder and harder to, so you either had to be only using their tool chains, so you get locked in, and then you get locked into their cost structures, and then you get dictated by their speed of innovation. So then we said, okay, and that's when I actually met Vikas. I said, Vikas, you're in the UCS BU, what do we have so that I can make things a little simple? I don't only want to depend. So then Vikas said, we have this new server. So we started eating our own dog food. And so just to answer your question, I think it's very, very easy to start your AI ML journey in the cloud, because you have one click, you have nice GUI-based tools, but and believe me, you can get a lot of work done, initial work done. But if you have the need for scale, because when we were doing AutoML, we were burning GPU cycles like crazy. Like burning is literally burning for weeks, and our bills just kept going, it just skyrocketed. And especially before some of these academic conferences, your spot instance prices become higher than, it becomes double. It's just crazy. So, and they're not cheap. And it's very hard to manage your budget. And this was only for 5 people. So now look, a typical enterprise data science team has usually, if you look at a retail company, 50 to 100 people. And not even a web scale. Web scale, hundreds of people. But even a mid-sized retail company would have 50 to 100 people. And each person is going to consume a couple of GPU servers, if not more, and with 8 GPUs. And you can just do the math on AWS or Azure or GKE. And I think that, and then I think on-prem becomes compelling. And once on-prem becomes compelling, then the lifecycle management question becomes really important. Because if you train something, you want the flexibility to maybe do the inference in the cloud. Another example that we found out, many customers, their long-term data is sitting in on-premise data lakes for years. But their inference stuff, they have a SaaS app, and the inference is happening in the SaaS app, which is typically running in a public cloud. So you have to go back and forth. Because, yeah, go ahead.
Thank you. One more question to follow up on that. So if you do the on-prem and do it yourself, gain scale or whatever, how do you get around the training issue where those platforms in public clouds are almost always pre-trained, so you can just use that pretty much readily for most of the basic AI capabilities? Mm-hmm. But on-prem, if you build it yourself, you need to, I'm guessing, train it, staff feed, need data to train the models. If it isn't,
So to answer your question, it depends on your use case. If you just want to identify a cat and dog, those models are readily available. So you can run it anywhere, be it on-prem or cloud.
Even on GitHub.
Yeah, they're on GitHub.
Lots of models on GitHub.
Yeah, but if you want your custom model, so if you think about what is a corporate asset right now in the AI and ML world as we move forward, it's your custom trained models. That's your corporate asset, because you invested in a data scientist or maybe a team of data scientists to build this corporate asset. And actually, people say that data is valuable. I would conjecture that these models, the derived corporate assets around models, are an order or two magnitude in terms of value. So that you anyway have to do.